Dear students, in this video I am going to introduce a new concept. It is combinations. So far we have seen permutations. In the topic permutations, we have solved some problems also and we have find out the properties of permutations and so on. And now I am going to start the next concept, combinations. Combination means just a selection of objects. What is the difference between permutation and combination? Permutation means arrangement or ordering of objects. And permutation means selecting the objects. After selecting the objects, we have to arrange or ordering the objects. That is permutation. But combination means just grouping the objects or selection of objects only. Here there is in the combination there is no question of arrangements or ordering. Just selection only the method of combination. Combination is just we are selecting the objects or grouping the objects. For example, there are three students, Arun, Babu, Chandran. See, ABC are three numbers or three alphabets, or otherwise Arun, Babu and Chandran are three students. Out of these three students, I am going to select two students. I am going to select two numbers. Two students. What are they? AB, AC and BC. These are the selections. There is no other selection. Now grouping of objects. So A and B, A and C, B and C. There are three selections only. After selecting this, we can order BA, CA and CB like that. That is permutation. After selecting AB, AC, BC, you can consider BA, CA, CB. Okay, this is permutation. Arrangements, after selecting the students, we are arranging or ordering. But in this case, this is only combination. Combination means, I already told you, it is just a selection. It is denoted by, out of three students, we are selecting two. So 3C2, number of combinations of three things taken two at a time. This is combination symbol, 3C2. Number of combinations of three things taken two at a time. Whereas this is 3P2, number of permutations of three things taken two at a time. 3P2 is, 3 into 2, that is equal to 6. 1, 2, 3, 4, 5, 6. Here 3C2 is only 1, 2, 3 only. So from 3P2 is 6 numbers, 3C2 is 3. From this we can see combination is less than number of permutations. So 3C2 is less than 3P2, or otherwise 3P2 is greater than 3C2. Permutation is always greater than the combination. Like that, this is an example. I am selecting two students out of the three students. This is a combination. And one more thing, if I select out of, say, another example, say for example A, B, C, D. From these four things, I am going to select 3 and I will continue here. Next, after erasing this, I will continue. Okay? Next example, number of combinations of 4 things taken 3 at a time. Here, there are 4 objects are given, A, B, C and D. Out of these 4 objects, I am going to select 3. Combination means selection, I told you. This is A, B, C, A, B, C, A, C, D, A, B, C, A, C, D, A, B, C, ABCD, and BCD, ABD. See, these are the four combinations only, selections: A, B, C, A, C, D, B, C, D, and A, B, D. These are the four combinations. So, out of four things, the combinations of four things that I can create at a time is 4C3. This is answer is 4. 1, 2, 3, 4 things. You know, the same if it is in the permutation, number of permutations of four things I can create at a time. That is 4P3. You know, 4P3 is 24, you know. 4 into 3 into 2. 4P3 is 4 into 3 into 2, you know. Therefore, 12 2s are 24. How you get 24? These three can be arranged or ordering into 6 times. ABC, ACB, BAC, BCA, CAB, CBA, like that. So, out of these 4 A, B, C, D, 4 objects, I can select 3 objects in 4 times. 4 ways, that is ABC, ACD, BCD, ABD, like that. And the BCD, ABC can be expressed as arranged or ordering as 6 times. How they are arranged? You get ABC, the arrangement ABC itself. This is one arrangement. ACB and BAC, BCA and ABC, ACB, BAC, BCA and CAB and CBA. These 6 arrangements. Similarly, here also on 6 arrangement, ACD can be, here also on 6 arrangement, and ABD can be arranged in 6. Therefore, 4P3 is 24. 1, 2, 3, 4, 6 are 24. Each and every selection can be arranged in 6 ways. Out of these 4 combinations, we can arrange into each combination into 6 ways, therefore totally 24 ways. Therefore 4P3 24. Here also 4P3 is greater than 4C3. See, every time the combination is less than the permutation. And also one more thing you consider is 4C3 is 4P3. 4P3, you know, 24 is 4 into 6, 24. Because 4 6 are there. 1, 2, 3, 4, 4 6. That is, 4 is, you know, 4C3. 6 can be expressed as 3 factorial. So 4P3 is equal to 4C3 into 3 factorial. The number 3 is in multiplied. 4P3 is, you consider 4C3 and multiply the 4C3 term into 3 factorial. The number in the combination, the number of selections into factorial times of 4C3. Similarly, in the previous example, I derived what is that 3P2 equal to 3C2 into 2 factorial. 3P2 is 6, that is 3C2. 3P2 is 6, you know, that is 3C2, you know, 3 things, and 2 factorial is 2, so this is 6. That is 3P2 equal to 3C2 into that 2 factorial. So, like that, now I am comparing permutation and combination. I am arranging the relation between permutations and combinations. From this, I can consider NPR equal to, now I generalize that, NPR equal to NCR into R factorial. number of combinations of n things taken R at a time is NCR into R factorial is NPR. So NPR is equal to NCR into R factorial. From this expression, I am going to derive the result for NCR. See, this is our idea. Okay. Now, relation between NPR and NCR. You know NPR equal to NCR into R factorial, or otherwise NCR equal to NPR by R factorial. If you bring this R factorial to the left hand side, it becomes NPR by R factorial, which is equal to NCR, because we want the value of NCR. NCR equal to, you know, NPR, n factorial by n minus R factorial, you know. NPR is n factorial by n minus R factorial, we know the result for NPR. We derived that also in the topic permutation. So, if you divide by R factorial, so NCR equal to NPR, NPR is n factorial by n minus R factorial and divided by R factorial. That's all. So NCR equal to n factorial by R factorial into n minus R factorial. You can rewrite this as R factorial. Generally we can write it as first R factorial and then n minus R factorial. NCR equal to n factorial by n minus R factorial, and already our R factorial in the denominator. Therefore NCR equal to n factorial by R factorial into n minus R factorial, or n minus R factorial into R factorial. Both are same, one and the same. So formula for NCR is n factorial by R factorial into n minus R factorial. This is our result for NCR. Okay. So far we have derived that. What is that? 4P3 equal to NPR equal to n factorial 4 factorial by 4 minus 3. What is that? 1 factorial. That is 4 factorial. 4 minus 3 is 1. 1 factorial is 1. That is 4 factorial. That is equal to 24. Whereas 4C3 is equal to n factorial by R factorial into n minus R factorial. That formula. N factorial by 3 factorial into n minus R, 4 minus 3. 4 factorial by 3 factorial into 4 minus 3 is 1 factorial. 1 factorial is 1. 1 factorial is 1. Therefore 4 factorial by 3 factorial into 1 factorial is 3 factorial. That is 4 factorial is 24 by 3 factorial is 6. Therefore you get 4. So 4C3 we derived as 4 already. 4P3 is 24. 4C3 is 4. One more thing. Simply we can write it as NCR equal to NPR by R factorial, you know NPR is n into n minus 1 etc. n minus R minus 1 is the last term we have derived in the case of NPR, and I will explain further. Okay? See, NCR equal to n factorial by R factorial n minus R factorial, where n and R are integers, and also one condition, that is that R is less than or equal to n but greater than or equal to 0. You consider this, NCR is n factorial by R factorial n minus R factorial, and R is greater than or equal to 0 but less than or equal to n. You can remember that R is always less than or equal to n but greater than 0. This is the condition you have to remember. And one more thing, we know NPR equal to n into n minus 1 into n minus 2 etc. all terms That is, we can write it as n minus r minus 1. That's our idea. NPR is, that is 4p3. That means 4 into 3 into 4 minus 1, 4 minus 2. N minus r minus 1. If it is 3 times you have to reduce. See, if it is r terms you have to reduce. N is also one term. So, next second term n minus 1, third term n minus 2, fourth term n minus 3, rth term n minus r minus 1. That is our NPR value. If you divide by r factorial, it becomes NCR. If it is NPR, it can be expressed as n into n minus 1 into n minus 2 into etc. n minus r plus 1. If you take that bar common, if you bring this minus inside, minus r minus plus 1, n minus r plus 1. If you divide by r factorial, this becomes NCR. NCR equal to NPR, n into n minus 1 into n minus 2 into etc. n minus r minus 1 or n minus r plus 1 divided by r factorial. NCR equal to NPR by r factorial. This is the idea. NCR equal to NPR by r factorial. This idea. I am writing NPR is expanded form. N into n minus etc. n minus r minus 1. Why I am writing this is, if you want to find out 4p3, this 4c3 is 4p3, 4 into 3 into 2 by 3 factorial, that is 1 into 2 into 3. The rule, it is 3 factorial. Rule, NCR equal to NPR by r factorial. NPR is 4 into 3 into 2 by 3 factorial, that is 4 into 3 into 2 by 3 factorial is 1 into 2 into 3. These 3 2s are 6 cancel. 4 by 1 is 4. So 4c3 is 4. We have derived already. Like that, we have to find out the value of 4c3. If you divide by the r factorial by NPR, you will get the value of NCR. Now, one more example. 10c4 equal to 10 into 4 times you reduce 10 into 9 into 8 into 7. 10 into 9 into 8 into 7 because 4 is there. 4 factorial. 1 into 2 into 3 into 4. That's all. NPR by 4 factorial to find out. So 10c4 is 10 into 9 into 87 is NPR. This is only, numerator is only NPR. 4 times you have to reduce 10 into 9 into 87 only. Whereas for NCR, you have to divide by 4 factorial. NPR should be divided by 4 factorial. We can simplify. What is that? 2 4s are 8. 3 3s are 9. 10 into 3 30. 30 into 7 210. So 10c4 is 210. Like that, you have to determine the values of combination of the things, anything taken all at a time. And these are the methods of solving the simple problems. Okay? So, after finding the values like that, I am going to find out the properties. I am going to list out the properties of combination. And that properties of combination we will continue in our next video. Thank you.